Okay, so now we'll move on with Adam Nayak from the United States.
Hi, everybody. My name is Adam Nayak, and I go to Stanford University in California. So ever since I was little, I've been really passionate about the environment. And I grew up 4 blocks from a local stream in Portland, Oregon, in the city. And in my free time, my sister and I would go down to the stream to play in the water and look for fish. But we never found any. And so this really started my research process. My question was, why aren't there any fish in the stream, and what can we do to solve this problem? And so due to urbanization and urban growth, we've experienced severe losses in wetlands. And so with increases in impervious surfaces, and impervious surfaces include things like roads, concrete, pavement, large parking lots, we have been experiencing a lot of losses in our natural environment, a lot of losses in green spaces. And with increases in impervious surfaces, we're seeing a lot of risk to increase in things like flooding hazard and water quality, because impervious surfaces don't allow for infiltration of water from rainfall or snowmelt into the soil. And so because of this, the rain will flow directly into the stream, and this will lead to high peak flows in the winter months and very low flows in the summer months due to the lack of groundwater deposits in the recharge. And with this, we're seeing problems not only in water quality, because you have toxins and pollutants from the roads going directly into the streams, but also this increased risk to flooding hazard. And so my research question was how will increases in urbanization change flooding in the future, and what changes can be implemented to mitigate the effects of urban development? And so my methods included the investigation of 4 urban watersheds within the Portland, Oregon area. And there were 3 parts to my methodology. So I started with the historical evaluation, in which I looked to validate this relationship that I was seeing. So in this area, are there trends that I can see that really validate the relationship between urbanization and historical flood trends? And so I did see a relationship, so I proceeded to the second part of my investigation, which included a land use trend analysis. So using GIS and remotely sensed imagery, I was able to track changes in land use over 25 different classifications over 40 years. And with these trends, I could then predict for future changes. And then I was able to condense all of these values for different types of land use into a single impervious surface value. And then using this value, I could then model how floods would respond differently based upon increases in impervious surface. And so here we can see one of the projections that I was able to tabulate in the Johnson Creek watershed. And in blue, we have a flood from 1996, and then in red, there's a projected flood for 2045. And as you can see, this is a pretty significant difference. And of course, my question right away was, how can we fix this problem? What can we do to provide a solution? And so I turned to green infrastructure. So green infrastructure includes projects such as rain gardens, bioswales, green roofs, pervious pavement, basically different ways of integrating green spaces within urban environments. And so I was able to model the implementation of green infrastructure and found that this did serve as an effective solution. And so then I wanted to actually see how we could make a difference and how we could make a change within my community. So I brought my research to my local watershed council, and I brought it to the city. And I said, how can we use this to actually make change? And so with the Watershed Council, we developed the Stormwater Management Program, and we've been actually implementing these projects in Portland with business partnerships. And so we've contacted over 140 businesses and are now working on site-specific projects. And basically, the conclusions to my research not only include that remote sensing is a great tool for a land use change analysis, and that green infrastructure could serve as a great way to mediate wetland loss and help to prevent future flooding, but also that this idea of collaboration between the research community as well as the applied science community is really integral to making change. And we need to be using our research not only to inform policy decisions, but also make tangible impacts in our communities to promote change. Thank you.
Okay. Yes. Do we have some questions? Somewhere, if you have a question, please raise your hand. Seems like a very clear presentation. Oh, there we have someone.
Yeah? Okay. Hi. Well, you're talking about roads and asphalt and cements and stuff where you actually drive your car on. Well, how do they behave with these changes you're doing to the infrastructure around it, and do they protect the roads as well, or have you thought about that?
Yeah, so the projects, the green infrastructure projects are integrated into city spaces along the roads or along the concrete. So like, for example, you can use pervious concrete that actually allows for filtration through the concrete, or you could implement something like a bioswale, which basically transforms a parking strip into a means of practical filtration where you have plants that are really going to soak up a lot more of that water. So it's a way to integrate green spaces within urban environments while not affecting the infrastructure.
Cleverly done.
Thank you.
Do we have no more questions? Oh, we have a question over here.
Okay.
So you could.
So, assuming that these new green infrastructure would then be absorbing water, how would this work? Like, how would this be impacted by, for example, summers and winters? Because, for example, the freezing of this water within these, like this concrete, wouldn't that cause damage towards the infrastructure?
So different projects are going to be suited to different climates. So in Portland, where I was working, we don't really have weather that gets below freezing that often. So it's mostly just a huge amount of rain that we're trying to control for. In environments where you're going to have a lot of snow melt, you're going to use different types of projects. So the projects I was focusing on are really focused on trying to soak up that water so that it doesn't run directly off the pavement into the streams.
Okay, thank you.
We have time for one more question, if there is. Any more questions? Oh, then we thank you again. Thank you so much.
Thank you.